either form. We know how to find the vertex. And then what we've been doing is what we've previously done, which is the x-intercept, the y-intercept, domain, the range, right? Like we know how to do all of that. So this right here is technically going to be whenever, like what we did last time, it was like determine the degree. If you notice, standard and general form, the degree's 2, right? So, but whenever we actually were like seeing, is it a function, is it not, our degrees are higher. And so this is what we do if you have a problem like that. You obviously can just tell that it's very clear it's not a standard form or a general form, right? And it starts asking you different questions. Standard and general, it was a parabola, right? So both of the ends of the graph would open either up or they'd open down. So for these functions, we're gonna have something that kind of does this, right? So we don't know for sure. They're not both gonna be in the same direction every single time. So that's why we have this new process that we're gonna do, okay? It was a lot of writing on my end, so I kind of already wrote it, and I'm just gonna kind of expose a little bit at a time. My 9 a.m. class, there was some confusion with this one, like pretty important chunk of this lesson. So I like changed 2 problems and like added some other stuff. My hope is that there won't be that same confusion, okay? But if it is confusing, just let me know, okay? That is what I'm here for. Okay, so what we're gonna do today, this basically is just gonna end what we had previously started, so it should be 3.2 to my knowledge. Not really positive. Yeah, 3.2. So we're gonna find zeros and multiplicities. I just wrote multiplicity. And then this is going to be also what helps us know whether or not our graph is going to cross or touch and turn on the x-axis. So it can be really simply put here because we're going to be writing it multiple times throughout the lesson, okay? So depending on my multiplicity, that will tell me that my graph will either cross the x-axis or it'll touch it and turn it, like it'll kind of bounce. Okay, so I just wrote cross or touch and turn. And then I'm gonna like break down each thing, okay? So your zeros, when it tells us to find our zeros, we've done this even in chapter 2, our zeros is what makes the function 0. So when we actually have a function and we set it equal to 0, you know how we solve when we get like x equals 2, right? That's called a 0. Our value, what we just now found, x equals 2, that's a 0. You can also see them called roots, right? So, but usually it'll just be like, what are your zeros of the function? Well, whatever we get after we set it equal to 0, those are our zeros, okay? Okay, so the multiplicity, this is what is really confusing. So this is what I'm gonna try to make sure I say, even in just a couple of different ways so that hope everyone can get it. The multiplicity is the number of times you have that answer. So like I said, whenever we find our zeros, we have like x equals 2, right? Say whenever I'm actually in a factored form and I set everything equal to 0, and what I end up getting is like an x equals 2, x equals 2, x equals 1. Do you hear how I said x equals 2 twice? That's how many times I got that number, right? That's how many times I got that answer. So my multiplicity for that value would be 2. So, but it's gonna, I'll keep on talking about it. Okay, so the different multiplicities that we have are even or odd. If my multiplicity, I put gum in my mouth. If my multiplicity is an even multiplicity, that tells me that my graph at that value is going to touch and turn at my x-axis. If I find a value and it has an odd multiplicity, what it does is it actually crosses right there at that value. And then y'all, whenever we actually graph these, we're gonna need to know something called the max turning points. There's actually a couple of different chunks that you figure out and then like that helps you graph, but this is definitely one of them. We need to know what is the maximum amount of times that my graph can have a turning point, meaning like it changes direction. It does this, right? How many times can that happen? I figure that out by taking my degree and I subtract 1 from it. This doesn't necessarily mean that whatever I find here, that's how many turning points there are, but this is the maximum that's allowed, okay? And then this is a shortcut thing here, but we're actually, this is kind of where I want to end. This is where I want to come back to, okay? Okay, so we're actually going to do an example and kind of just apply what I just went over there, okay? So if you have a problem like this in your homework and it tells you to find the zeros and the multiplicity of, and it says f of x equals x cubed plus 3x squared, a negative x, and a negative 3. This is not a trinomial, right? I can't do the AC method. That has to be squared. Can't do quadratic formula. That has to be squared. Like all that previous stuff is whenever it's being squared. Right here, this is x cubed. What I do notice, though, is that this has 4 terms. Do you remember whenever we had the AC method problem? And what we would do is it would be 3 and we turn it into 4. And then we split it down the middle and pull out GCFs. This is technically like that. It's already 4 terms. So what I'm going to do is the way you factor this is the way that you would do. It's basically like the second half of an AC method problem. We're just going to split it down the middle. Factor by grouping. Literally group the first 2 terms together, group the second 2 terms together. And what we do here is pull the greatest common factors. Because my goal is to have things in parentheses, right? Those are factors. Okay, so let me see. Okay, I need to do this first. I wanted to tell you what we're going to do, but do you see how it says to find my zeros? I need to know what makes f of x equal 0. So when I'm doing my factoring, what I'm actually doing is seeing what makes it equal 0. So I'm going to go ahead and do 0, and then right here, this is where I'm going to factor it. Okay, so as far as the factoring techniques today, those I'm going to do rather quickly because like the other concepts I think are more important to go over. If you do get stuck after class, you can ask me, of course, email me or watch like the videos online, okay? But just make sure you let me know. Okay, so factoring this, I noticed that their greatest common factor would be x squared. That's all they have in common, so I'm going to go ahead and factor it. I do x cubed divided by x squared. Exponent rule says to keep and subtract. And then 3x squared divided by x squared, that would give me a positive 3. I bring down my negative sign. These don't have a common factor, but you have to write something. So what we do is we put a 1. Because I know for a fact, right, that both of those can be divided by 1. That's like mathematically, though, like you need that placeholder. If you do this division, x divided by 1, that would be x. Signs are the same, so it's positive. 3 divided by 1, that would be 3. Signs are the same, so it's positive. Okay, so now I have, or I'm sorry, let me say x. I have 0 equals. Now you can write it either way. You can put these in a set of parentheses together and just bring down one of these. What I usually do is I bring down one of the matching factors, right? I only need one of them. And then this leftover, that goes into a set of factors right here. Okay, so I need to notice right here, if you see x squared minus 1 in parentheses, that's actually something that can be evaluated further. That's a difference of squares, okay? Trying to think, I know we went over it, but it'd probably be like the beginning of the semester. That actually can be like, that's like a condensed form. It can be expanded into x minus 1, x plus 1, right? And I'm literally doing this just so as far as the multiplicity is concerned, it makes a little bit more sense. When I find the multiplicity in this form, that's kind of what started the confusion, okay? And if you don't believe me, if y'all FOIL this, you'll get right back to this. That's why I can write it like that. Now, I needed to see what values make my function equal 0, right? Those were my zeros. So now that I have factors, now that I have parentheses set equal to 0, you set each of them equal to 0, right? Like we've been doing this. So I have x plus 3 equals 0, and I have an x minus 1 equals 0, and I have an x plus 1 equals 0, right? Now, solving these, y'all, what do I get? X, Yep, -3 plus 1 minus 1, right? So if you look at this, I noticed that I have 3 solutions. The fact that my leading variable was cubed, that kind of lets me know I should have 3 solutions. But once I have these, my goal is to actually tell them what my zeros are, right? So let me do this. My zeros, how did I write it here? Because I didn't like the way I wrote it here. My zeros, I have a -3, comma 1, comma -1, right? Those are what I just found. My x equals these values. I don't know if I'll be able to write everything here, but I do have more space right here, okay? Now, if I look at this x equals -3, y'all, how many times do I have that answer? How many times do I have written x equals -3? 1 time. That's your multiplicity, okay? You literally, this is what I wrote. Like on my regular initial notes was just multiplicity is 1. How many times do I have x equal 1? I have that 1 time, right? So my multiplicity here is also 1. I think in the homework, it's way more wordy, right? And like you're just filling in little small text fields. And it'll be like at the 0, and you might type in -3. The graph, you have to pick the one that tells you what this multiplicity does. Do you see what I'm saying? So it's kind of taking all the information on that last page and this page, and it's like in a sentence, and you're just filling in the numerical values, okay? So right here, I have x equals -1 1 time. That means my multiplicity is 1. So, I mean, I have it written here, but if you wanted to rewrite it here, you could say -3 has a multiplicity of 1. -1 has a multiplicity, like you could actually write all that out, okay? Now, as far as it crossing or turning, look back at your first page. If my multiplicity was an even number, what happens is it touches and it turns, it bounces, right? It changes direction. But if my multiplicity is odd, then it actually crosses on the x-axis at that value. So what this is telling me is at the x value -3, because I have an odd multiplicity, what happens is my graph is going to cross right there at x equals -3. So I could just write cross, cross, cross. And what I'm saying as far as the homework is it's actually going to ask you like, there are 3 zeros. And at -3, the multiplicity is 1. It says it's odd, so it crosses. Like it's going to, yeah. Did that make sense, though? I've known how to do this, right? I've known how to do this. I've known how to do this. This is what we've been going over. This is what should be known. This right here is what's new. How many times do you see the answer? That's also called your multiplicity. So I have that answer once. My multiplicity is 1. Something else that's new. Odd crosses, even, touch, and turn. The way I've always remembered it is even, like I think of the number 2, right? The directions is toss and turn. Toss. Turn, touch, and turn. I'm not saying the right words. Touch and turn. How many words am I saying, though? Touch and turn. So even, touch, and turn, right? Odd, I think of the number 1. The direction when it's odd is cross. So I kind of compare it with what does it do at that x-axis. If I've got 2 words, that's even. So that happens at my even multiplicity. If I've got 1 direction, which says cross, that's 1, that's odd, and that happens when my multiplicity is odd. So you can kind of see it, right, in those different ways. Okay, so let's do this other one. I had another factoring problem in the other class, which just involved a GCF needing to be pulled out first, but the leading coefficient was negative, so that also gets pulled out. But as far as graphing it's concerned, I think this is a good example to see where it's going whenever it tells you to graph something. And look, I'll show y'all what I mean. This was the example right here. Whoop. It never lets me touch it. Do you see that negative x to the 4th and then all of that? And then I pull a GCF and then I can factor it with the AC method and then I get 2 factors and I've got all that going on, right? But I think this will hopefully make more sense for the graphing examples. Okay, so same problem. What are your zeros? and what is the multiplicity of those zeros, right? So my zeros are found when my f of x right here is equal to 0. So I'm literally going to change f of x to 0. That's how you find your zeros, right? Y'all, the equation formula little right here that I have to the right is technically already in factored form. I'm going to show you two different things, okay? Two different ways to see this problem, and my hope is that the multiplicities make sense both times. But, okay, so I already have it in factored form, right? Okay, so what you do is you set each factor equal to 0, right? That's how we've been solving. This x, of course I would say that because that's not what I wanted to say. This 8 does not have an x, right? So if I set that equal to 0, I'm saying 8 equals 0, which is a contradiction, like that breaks math. We don't do that. It's just like a number, so it kind of just goes away. I'm not setting that equal to 0. I'm going to set my factors equal to 0. So this gets set equal to 0, and this gets set equal to 0, right? Now, because it's in this form with this factor being squared, I'm writing that whole thing. So I'm going to do x plus 3 equals 0. It's being raised to the first power, y'all. That means there's one of them, right? There's one of these. So I can just bring down these two terms. This, if you want to do it this way, and you include that square, this is the one way that you can do it. Let's solve these. This is what? X equals -3. And then this would be what? Take the square root of both sides, right? To cancel that square, I get x minus 3 equals, this would be plus or minus the square root of 0, right? But the square root of 0 is just 0, and technically there's not a plus or a minus. 0 is just 0. So this is me just kind of skipping a few steps, y'all, okay? What would I do here? Move my 3 over, right? So x equals 3. Now, as far as finding the multiplicities are concerned, because I left it in this form and set it equal to 0, if you look right here, this multiplicity would just be 1. I have that answer one time. Some people will understand this way. A lot of people probably won't, but this is like the shortened, easier way if it makes sense. This 3 actually has a multiplicity of 2. And the reason why it has a multiplicity of 2 is because what I set equal to 0, the factor I set equal to 0, what I was looking at, it was being raised to the second power. That's telling me I actually had 2 of these factors, okay? So this would have a multiplicity of 2. Now, I'm going to show you in a different way. I'm just saying if your exponent here is like 4, you probably don't want to do this 4 different times. Do you see what I'm saying? That's why it's kind of like this is a shortcut. Real quickly, if I did this set equal to 0, I still get this, right? So I would have that factor equal to 0, and I'm going to get x equals -3. Oh, why did I do that? That's a multiplicity of 1, sorry. Which has a multiplicity of 1, right? Same thing. This is that part I'm trying to show you that could be different. Because this says x minus 3 squared, doesn't that mean I can write x minus 3 times x minus 3? Like that was condensed. I can actually write it as 2 sets of parentheses. That's what that means. This is literally saying, that's literally what that's saying, right? So what I would do here is set them both equal to 0. And I would get x equals 3 and x equals 3. Now, hopefully what I've said as far as my multiplicities are concerned, the multiplicity of a 0 is how many times you have that number, right, as an answer. How many times do I have x equals 3? Twice. So my multiplicity is 2. This is a keep it in like a real condensed factored form, but just don't forget what its original exponent was, right? Because here's 1, here's a 2, here's 1, here's the 2, right? Those match. Or if it's something that's like cubed or whatever, you can actually write those factors out that many times. And then because they're the same factor, you could solve it once and then just see how many times you have. You got two different options there. In my mind, this makes the most sense because I didn't have to write this and I didn't have to write this. Do you see what I'm saying? Okay. So here, it really doesn't matter because they're both the same. But for my zeros, what I have for my zeros are a what? I've got a -3 and a 3. You just write 3 once. Those are zeros, okay? There's only one +3 on the x-axis anyways. The only reason why I need to know how many times I see that number is to see whether or not it crosses or touches and turns. My multiplicities, just lining them up under each other, y'all. I get 1 and 2. And then let's call this star. Whether or not it crosses or touches and turns, because this is odd, right? I already think of the number 1 when I think of odd. That's going to be that one direction it tells me to do, which is cross. I'm lazy. I think all math people are lazy. If I can write one letter, I'm going to do it. And that happens a lot soon. Okay, so then for my 0 of 3, right? So one of my values of my zeros is the actual number 3. That multiplicity is 2 because I had that answer twice. Because it's even, I actually touch and turn, okay? That just became TT. Just happened. Okay, so does that make sense though, y'all, as far as multiplicities? How many times you see the answer, or there's literal shortcuts, like you do a couple problems and you notice you don't even really have to factor anymore. What happens is like you kind of just look at the exponents and stuff. But if that does not make sense, you'll have to let me know. I can't read your mind. Okay, so y'all write that down. It's in behavior.